Jai Hind everyone, I am Anuradha Dhumale, Assistant Professor of Computer Science and Engineering Department of Ajay Kumar Garg Engineering College. Today in this lecture, we are covering the subject that is the computer network, and the topic which I covered in today's lecture, that is the network layer. So, the network layer is the third layer of the OSI model, right? In the OSI model, there are various types of layers. There are 7 types of layers. The first is the physical layer, second is the data link layer, third is the network layer, fourth is the transport layer, after that session layer, presentation layer, and the last is the application layer. So, we are discussing the network layer here, and the network layer is the third layer of the OSI model. Now, if we want to transfer the data from source to destinations, the data is transferred in the format of packet. At a particular layer, at the different types of layer, there are different format for the transferring of data. Like in DLL, that is data link layer, the data is transferred in the format of frames. Similarly, in the network layer, we are transferring the data in the format of packets. Okay. As we know, the data link layer, in the data link layer, the data is transferred within a network. That means from source to host destinations, but within the network. But in the network layer, we can transfer the data, we can transfer the packet across the multiple network. Network layer services. The network layer is a part of communication process in computer network. The main job of the computer network is the data packet between, move the data packets between different networks. Okay, it helps route these packets from the sender to the receiver across multiple paths and network. At the network layer, the data is sent to the network to for the receiver. It goes to the receiver within the network, but it finds the different paths. It takes the different paths. It finds the different paths to reach to the destination. After that, network to network connections enable the internet to functions. These connections happen at the network layer, which sends the data packets between different network. Okay, as we know, we are using the network device here, that is the router. Router is used to connect the multiple network here. Network layer is the third layer of the OSI model, and the protocol which are used in this network layer, that is the internet protocol. Okay, the internet protocol is a key protocol used at this layer, along with other protocols for routing, testing, and the encryptions. The internet protocol is used for routing, testing, and for the encryptions. Okay. After that, what the different type of services network layer provided. First, when the data is transferred from one host to the another host, that is from one source to the destination, it needs the logical address. It needs the address to reach to the destination. How data does know that where he want to reach, where he want to go? Then we add their logical address. Logical address is of 32-bit address, that is nothing but the IP address. Okay, packetizing. When the data comes from the transport layer, it encapsulate into the encapsulate the data at the source, and it sends to the destination. After that, the destination receiver decapsulate that data. In network layer, the host to host delivery is done. That means the data is not directly sent to the receiver. In between the sender and receiver, there are multiple routers are attached. We use the routers. We use the router device to connect to the multiple network, right? So, when one sender is there, one receiver is there. Okay, if one sender is there and one receiver is there, in between different routers are attached. So, the data is go from this sender to this router 1, after that to this router 2. That means the host to host delivery is there. After that, forwarding. Forwarding means the data is transferred from host to source to destination. Fragmentation and reassembly of the packets. This is the very important term in the network layer, that is fragmentation and reassembly. Means if the data which a sender want to send is greater than the size of the bandwidth of the channel, then, or we can say that if the capacity of the receiver is less than the capacity of the sender, then we can fragment that data. Okay, we can divide that data into the multiple fragments and then send that data to the destination. That fragment is goes from the different through the different route. They takes the different route with the help of routing algorithm. They find the path, different path, and reach to the destination. After that, logical subnetting. If we have a big network, then it is very difficult for the maintenance of the network or for providing the security to the network. So that we are using here the subnetting, that is we divide the network into the different parts. There are subnetting is the different individual topic is here. Subnetting is of two types, that is fixed length subnet mask and the variable length subnet mask. After that, routing is here. Routing, with the help of routing, the packet which is transferred from source to destination find the different path to reach to the destination. So this is the diagram of one network where one A station is there and another B, C, D, E and F. Okay, this B, C and E are the routers which is used to connect for the different network here. Okay, when A wants to send the data to the D, then it goes from station A to the router B, then router B to the router C. After that, it reach to the destination D. That means it goes from hop to hop delivery. It is here, hop to hop delivery is here. Okay, this is end to end delivery. After that, logical addressing. In network layer, logical addressing is very important term. Logical address is used to identify the source and the destination. Communication at the network layer is host to host, computer to computer. That is, computer somewhere in the world needs to communicate with another computer somewhere else in the world. That is, one network is there and one network is far away from the previous network. Then also we can transfer or we can communicate through the network layer. Okay, the data packet travel through the internet, several interconnected LANs or WANs. For this communication, we need logical global addressing system to help distinguish the source and destination located at the different location. We need the logical addressing to identify the destination to which we are communicating. For that reason, we need here the global address, and global address is nothing but the logical address, that is the IP address. Thus, the network layer adds the header that include the logical address. Now, when the data comes from the transport layer to the network layer adds its header to this data. Okay, in that header there is logical address of the sender and receiver to the packet coming from the upper layer. Okay, when data is come from the transport layer, the network layer adds its header to that data, and in that particular header there is a logical address of the sender and the receiver. Then what is logical address? Logical address is Internet Protocol version 4. There are two types of IP addresses. We can say IPv4 and IPv6. IPv4 and IPv6 are nothing but the versions. Here we are using the IPv4 addresses. That IPv4 addresses are the 32-bit addresses. Okay, IPv4 address is the 32-bit address that uniquely and universally define the connection of the device, computer or a router to the internet. We can say that when there is a multiple host in particular network, we assign a unique IP address to that particular host. If in one network there is a 10 hosts are there, then we are assigning 10 IP addresses to that 10 hosts, and that IP address are unique. That IP address, the IP address we are not repeating for the other device or other host also. And that IP address is universally accepted by the every node which is available, which is presented in the network. An IPv4 address is a 32-bit long. That means the address space of IPv4 is nothing but 2 to the power 32. Okay, 2 to the power 32. This is the number, that is 4,294,967,296. This means this much of IP addresses are available in IPv4 versions. If there are various devices available in the network, we can provide the IP addresses, that is 2 raised to the power 32. That means this much of IP addresses we can generate. There are two prevalent notation to show an IPv4 address. How IP address is represented? There is a notation for the IP addresses. This is the binary notation and this is the decimal notation. Okay, decimal notation is here 128.11.3.31. This is decimal notation. This is the decimal dotted notation. In this decimal notation, the 1 octet is of 8 bit and we are using the 4 octet. Okay, 8 bit of 4 octet. Here the address in IPv4, the address is 32, 2 to the power 32 and 32 bit long, and in IPv6 it's 128 bit long. Okay. Now, in general, we all know the IP addresses. We regularly can see the IP address. We are using the PCs, laptop that also have the IP address. So we have the general knowledge of about this IP address. So here is one question that find the error if any find the error if any in the following IPv4 addresses. There are 4 IP addresses are given. We have to find the error. Here 111.56.0.45.78. In the first, that is 045. The IP address is not leading with the 0. So the error is 045. In second IP addresses, that is 221.34.7.8.20. This is having the 5 octet. Okay, and IPv4 is always having the 4 octet. So this is the error. After that, 75.45.301.14. Here 301. 301 is exceeding the limit, that is the maximum limit is 255. Okay, 255. 0 to 255, that means 256 bit is here. So here 301. This is the number which is greater than 255. After that 111.00010.23.14.67. This is the combination of binary and the decimal. Okay, this is the combination of binary and decimal, and this is not allowed into the mixture of binary notation and dotted decimal notation is not allowed. Okay. The next is the logical addressing. Logical addressing, IPv4 addressing is of two types. There are two types of IPv4 addressing, that is classful addressing and classless addressing. Classful addressing schemes is becoming absolute. Okay, the classful addressing is absolute. We briefly discussed that classful addressing is, in classful addressing, the address space is divided into 5 classes. Okay, the classful address is, the address space, the total address space is 2 to the power 32, right? 2 to the power 32, that means that some number 429 something, 4 crore something number is there. That address space is divided into the 5 classes: class A, class B, class C, class D and class E. Each class occupies some part of the address space. Okay, each class occupies some part of the whole address space. Here the binary notation for the class A, B, C, D and E, and here the decimal notation for the class A, B, C, D and E. There is some range for these. First we will see the binary. In binary, there are, in class A, 0 bit is reserved. This is the net ID that is represented in yellow part. This is the net ID which is of 8 bit, and this is the host ID that is of 24 bit. In this 8 bit, the 0 bit is fixed. That means this, if the IP address is starting from the 0, that means the first bit is 0, 0, 1, 2, 0, 1, 0, 0, 1, 1, like this. If this is starting from 0, that we can understand that that address is belong to the class A. After that, if the bit is starting from 1, 0, okay, 1, 0, 0, 1, 1, like this, so we can consider that that IP address is belonging to the class B address. After that, if the starting bit is from 110, 110, 1, 1, 2, 3, 4, 5, 6, 7, 8, like this. If these 3 first bit are 110, then that IP address is belonging to the class C address. After that, class D. If the bit is starting from 1110, that is 4 bit are reserved for the class D, and 4 bit, that is 1111, is reserved for class E. If the IP address is starting from 1110, that means that IP address is starting belonging to the class D, and if all the ones are there, 4 bit of 1 is there, then that address is belonging to the class E address. Similarly, here for the decimal notation, we can see that here class A, class B, class C, class D and class E. Okay. Now the range for the class A address is 0 to 127. 0 to 127. For class B, range is 128 to 198. If we can see, there is a IP address which is belonging, we can see there is a IP address that is 192.168.0.1. So we can identify this IP address is belonging from class C, belonging to class C. The range is starting from the class C. The range from 192 to 223, in between any number is there, then that IP address is belonging to the class C. Similarly, here for class D, the range is 224 to 239. For class E, the range is 240 to 255. Okay, these are the whole 5 classes: class A, B, C, D and E. Mostly we are using the class A, B, C and class D and E are class D and E are not used. Class D is used for research or some other purpose. Okay, class E also is for the future use. Okay. Next, ID, net ID and the host ID. In this, now we can understand what is the net ID and what is the host ID. As we can see, there is a partition of address space into the 5 classes, that is class A, class B, class C, class D and class E. In classful addressing, an IP address in class A, B or C is divided into net ID and the host ID. Okay. See, here class A, class B and class C. These 3 classes are divided into net ID and to the host ID. Here for class A, the net ID is 8-bit, that is 1 byte, 8-bit, and host ID is of 24-bit. Here 8-bit and this is 24-bit. Here net ID for class B is 16-bit and for the host ID in class B we are using 16-bit. Here class C we are using 24-bit for the net ID and for the host ID we are using 8-bit. Okay. Class D and class E are not partitioned into the net ID and to the host ID. Here class D is used for the multicasting address, where multicasting is nothing but when there is a one sender and multiple receiver are there, and class E is reserved for the future use. For the research purpose we are reserved these class E addresses. Similarly, there is one more example. Find the class of each address. We need to find out the class of each IP address. Here 2 are the binary IP addresses and here 2 are the decimal dotted IP addresses. We need to identify the class of these IP addresses. So let's start. The first IP address is starting from the 0. See, the first bit is the 0. So this is the class A address. This IP address is belonging to the class A. Now in second, class B, 110 bit is reserved, and as we can see, the 110 bit is reserved in binary for the class C address. So this is the class C address. Here the range is starting from 14.23.120.8. Here the first octet is starting from first decimal number is starting from 14, and this 14 is belonging to the range that is 0 to 127, and 0 to 127 is the range of class A. Similarly, 252.5.15.111. This range is belonging to the 240 to 255, that is class E. Okay. So these are the 4 IP addresses which is we have to identify the class of that addresses. After that, classes and blocks. Okay, here the number of blocks we are using. Here one problem with the classful addressing is that each class is divided into the fixed number of blocks, with each block having a fixed size. Okay, if I can say that if I want 1000 of IP addresses, I want to assign the 1000 of IP addresses. So here what happened, when we are requesting for the IP addresses, the whole class is assigned to you. Okay, there is not particular that number of IP address, means when the user required the 1000 of IP addresses, then In classful addressing, only 1000 of addresses will not be given. The whole class is allowed to you for the IP addresses. Okay. So there is a lots of wastage of money, wastage of IP addresses here. Okay. Here the number of blocks are, that is in class A, 2 to the power 7 is equals to 128. 128. Why this is 2 to the power 7? Because 0 bit is reserved here. Okay. So remaining 2 to the power 7, that is 128. 2 to the power 14. Here 2 bits are reserved and the net ID is of 16 bit. From the 16, 2 bits are reserved. So here 2 to the power 14, that is 16.384 is for class B. 2 to the power 21, here 3 bit are reserved. So 2097152 is for class C. Okay. This is the block size. Block size will be here 24 bit of host address. So 2 to the power 24. Here 16 bit of host, that is 2 to the power 16. Block size are there. Here 24 bit of net ID and 8 bit of host ID. So 2 to the power 8, that is 256 blocks are there. Thank you.